Welcome to the Math Record. Today we'll be covering the CCML Geometry Contest 1 2017-2018 Division A. First, I'm sorry that the document is in a picture. I do not have the document, so I'll be using this to teach the content. Okay, number 1. Find the sum of the supplement and complement of an angle measuring 18.5. Okay, so since this is contest 1, usually you could just use your calculator. So if you have a supplement of an angle, it's just 180 minus that angle, so 180 minus 18.5. That's the supplement. The complement is just 90 minus 18.5, right? So if you plug that into your calculator and you add those two results together, you get an answer of 233 degrees. So that's your answer, 233. Okay, pretty simple so far. Number 2, solve for x. 2x to the power 2 plus 10x minus 12 is equal to 0. So we have 2x squared to the power 2 plus 10x minus 12 is equal to 0. Okay. So since 2 is already prime, I'm just going to assume that's 2 and just 1 here. So since we have a 12 and a 10 here, if we have a 3 and a 4, that's 8. Since this is minus and this is plus, that means one of them, the positive number has to be greater than the negative number when it multiplies out. So it has to be a 6 and a 2. Right, so that's 2x squared plus 12 minus 2, so that's plus 10, and then minus 12, okay. So the answer is x is equal to 1, or x is equal to negative 6. So usually I just write that as negative 1, and then comma, 1 comma negative 6. If there's more solutions, just put more commas. And then you don't get confused of using like or and. Because sometimes they're a little picky in the CCML of which words you have to use to describe like roots. Okay. Number 3. Use the diagram below for items 3 to 5. Okay. So you have QS, the intersection of QS and UQ, right? So the intersection of US and QU is just UQ. Basically just that simple. Okay? Now the union, which is like both of them combined together, so which is US and QU is just QS. Or SQ is the same thing. And that's number 4. Okay, so 3 and 4 are really simple. If you understand your notations, you should be fine. Okay, number 5. If the measure of QTS, okay, so this angle right here, QTS is equal to 89 degrees, 59 seconds, and 58 milliseconds, find QTR. Okay, it gives us right here that TR bisects QTS, right? So if we want QTR, it's just half of this angle. So how do we do this? Well, technically, all you have to really do is that you're gonna divide this by 2. But every single degree is equal to 60 second, and every single second is equal to 60 milliseconds. So how you could do this is that what do you divide to what is the number that you could go to 89, which is just 44, right? So we have 44. Actually, let's move this a bit down so that we have some room. So we have 44. That's going to be our degrees. Because that's 44 times 2 is 88. Minus that is 0 degrees. 0 degrees is the same thing as I said before. 1 degree is equal to 60 seconds. So if this is 1 degree less, just transfer it over. So it's just going to be 60. 1 degree left is 60 seconds. So 60 plus 59 is 119 seconds. Okay, so how big can we go to 119? Well, 120 is 60, so since this is lower than 120, that means we have to go to 59. So this is 59 seconds. So 2 times 59 is 118 minus, so you have 1 second left. As I said, 1 second is equal to 60 milliseconds, so just carry that 1 over. Forgot that 1 there. Carry that 1 over to this one, which adds another 60, so that's 118 milliseconds. So we already got 118 here, which is 59, right? So we don't have to do the math all over again, so that's 118 milliseconds, and that subtracts out to 0. So half of 89 degrees, 59 seconds, and 58 milliseconds is 44 degrees, 59 seconds, and 59 milliseconds. So this is your answer. Okay. Number 6. The vertex of an isosceles triangle is 12 less than the degree of a base triangle. Base angle. So let's kind of draw this. This is an isosceles triangle, so these two are the same. So they're, and we know these bases are basically the same also. And they set the vertex angle, which is this angle right here. The vertex angle of an isosceles triangle is 12 less than twice the base angle. So it'll be 2x minus 12. Right? And then you find the angle, find the measure of the largest angle of the triangle. So we have x plus 2x minus 12 is equal to 180, because an interior sum angle of a triangle is 180. So that's 4x minus 12 is equal to 180. You could use your calculator for this so you don't make any math mistakes. So 180 plus 12 divided by 4 is equal to 48. So x is equal to 48. Now that's only for these two angles, right? So you need to find the top angle, which is 2x minus 12. So 48 times 2 minus 12. So this angle is equal to 84. So they said find the measure of the larger angle. The larger angle is 84. So your answer is 84. 84 degrees, if you want to have the units. Okay. Number 7. Given the diagram below, with angle COL equals to 3 over 5x minus 3. Sorry if you can't see that. It's 3 over 5x minus 3 is the angle of COL. And COU, which they gave us, is equal to 5 over 3x plus 13. And they want us to find DOU, angle DOU. So they've given us COL and COU. So since they are supplementary angles, since they're like angles that are side by side and along the line, that means they're 180 degrees. So if you kind of use your calculator, 3/5 plus 5 over 3, you get 34 over 15x plus 10 is equal to 180. Right? So 180 minus 10 divided by 34 over 15, and you get 75. So x is equal to 75. So we need to find DOU. DOU is a vertical angle to COL, right? So we just need to find COL because they're basically the same thing. So plug in x back into COL. So 75 times 3 divided by 5, and then minus a 3, and you get 42. So the measure of DOU is 42 degrees. Basically just that simple. Okay, so that was number 7. Number 8. One angle of an acute triangle is 25 degrees. If another of the angles is x degrees, find an inequality that gives all possible values of x. Okay, so since this is a acute triangle, every single measure of the triangle has to be less than 90. Okay, because then it will be defined as a acute triangle. So if one of the measure is 25, right? Okay, so if you kind of think about it, we have a triangle. So if we kind of get we have a triangle like this, right? Then it makes a acute, it looks like an equilateral, but let's just say that's cute. So let's get a big picture, so something like this or something, right? So you have a acute triangle. Now, the next version from a acute triangle is a right, and after right is obtuse, right? So if you get something that is like here, oops, sorry about that, right? And you increase this angle to this side, to this bigger, then technically you just get a right angle. And if you increase it even more, you get to an obtuse. So the reason I'm explaining this is because the next up is 90 degrees. So if you kind of think about it, if we have a 90 degrees here, then we have 25 plus 90. And then since an interior angle of a triangle is 180, it's just 180 minus 25 minus 90, which gets us 65, right? So this will give us a right triangle, but we don't want a right triangle, right? So technically, we have a 65, which is going to be our value that we could, lowest value that we could get, because then it will be, because if we go any lower, right, we make that 64, then that would make 91. Now, if we make this 66, right, this has to be 89. Since they're all less than 90, then technically this is a acute triangle. So the lowest possible measure for x has to be 65, but it's not going to include 65. So usually how we write it is that we use a curvy bracket. A rectangular bracket, which is usually what I call it, is going to be including that 65. But since we're not including it, we're going to use this curvy bracket, which is 65. Okay. Now, what's the highest measure that we could go? Well, technically, the highest measure we could go is this 90, right? Right? We're not going to include that 90, but if we go to 89, then technically, it's just going to be this version. It's like switching these two angles around. So now this would have to be 66, right? That's all you have to do. So basically, it's just that simple. This is how we get the answer. So the answer for number 8 is 65 to 90, but not including 65 to 90. So and this is usually how you write it, which is, I forgot what's the proper name, but it's you could use this as your notation for your range or domain. Okay. Sorry about that. Now number 9. Points A, B, C, D, and F are plotted from left to right on the number line, with B and D trisecting AF and C and E trisecting BF. Okay, let's kind of do this on a number line first. So usually when I do this, I just only draw the first point and the last point. So we have A, and the last point we have is F. And the next sentence is that with B and D trisecting A and F. Okay, so we have B right here and D. Right, actually, let's get this a little better. So right here and right here. Okay, B and D. So they're trisecting each other. So all of these are equal length. And they said that C and E bisect BF. So this length is bisected by C and E. Okay. So we'll have something like right here and something like right here. Okay. So that's C and E. So if you think about it, this entire thing that we didn't mess with is in our beginning was 1/3. Because this entire thing is let's just define this as a length of 1. Then this is 1/3 of that length, right? And now we have B and D, right? So B and D is also 1/3, and D to F is also 1/3. Now we gotta think about this, because for B and D, from BD to DF, that's 2/3, right? Because A to B is 1/3. So if we have 2/3, and we're looking and CE trisects B, D, and F, then this length is just 1/3 of that 2/3, right? Because this length is the same as this length, is the same as this length. So with the remaining 2/3 of the length, and that 1/3 of the length, it's just 2/3 times 1/3, which is 2/9. Okay. So BC is 2/9. Okay. Same case could be applied for EF, so it's 2/9. So on the middle is also 2/9, but since CD to DE is the same length, because if you could think about it, B to D to D to F is equal length. So since C and E trisects B, D, and DF, you could logically think that C and E are gonna be the same distance away from D. So you could just say that since this is 2/9, you just divide by 2 is 1/9 and 1/9. So it's so if you kind of convert 1/3 to like a ninth, you could just have 3/9, right? So 3 plus 2 plus 1 plus 1 plus 2, that's equal to 9/9, which is 1, which makes sense because it should add up to 1. So now let's solve the question. If the coordinates of A and D are -8 and 16, okay? So this -8 and this 16, find C, okay? Find C. So the distance between these two is 24, right? Because 24 plus -8 is 16. So now we just need to look for this proportion in relationship to this proportion. So we know. So let's kind of think about this, right? So we have 2, we have 1/3, we have 3/9 plus 2/9 plus 1/9. That's 2 plus 1 plus 3. So that's 6/9, which is 2/3. So 2/3 is our total length. We just write a proportion down. So we have that is equal to our entire length, which is 24. Okay, divided. So the top portion is that we only want this length, right? So our length here is 2/9 plus 3/9, which is 5/9. And we have to look for x. So you kind of just use your calculator. We just solve for x. So we have 5 divided by 9, and then divided by 3/2, which is the same thing as multiplying by 3 and then divided by 2, right? Sorry about that. 5 divided by 9 times 3 divided by 2. Okay? Now that's equal to x divided by 24, so just multiply by 24 from both sides, and we get 20. So we get x is equal to 20. Right? So the length from A to C is 20. So 20 plus 8 is equal to 12. So the answer for number 9 for coordinate of C is just 12. Okay? Let's go to number 10. The supplement of an angle is 12 less than 7 times its complement. Okay, let's say our angle is x, right? The supplement of an angle is 180 minus x. And they said that this supplement is 12 less than 7 times its complement. So 7 times the complement, which is 90 minus x, right? The complement is 90 minus x. 7 times the complement. And then it's 12 less than that, so it's minus 12. Okay? So let's kind of simplify this. So we have 180 minus x is equal to 630 minus 7x minus 12. Now we get the x to one side and the numbers to the other side, so plus 7 to both sides, so that's 6x is equal to 630 minus 180 minus 12, which is 438. 438 divided by 6 is equal to 73. Okay? So 10, find the angle measure. So the angle measure is 73 degrees, which we were just looking for. So the answer is just 73. So basically this. It's just that simple. So all you had to do was create an equation. Okay, number 11. Increasing the length of a base of an isosceles triangle by 25% results in an equilateral triangle. Okay, since it's an isosceles triangle, right? And we have a base x. If you increase this by 25%, it results in an equilateral triangle. Since these two are the same, right? That means if I increase this by 25%, so I multiply this by 1.25, because that's increased by 25%, then technically it will be equal to the other sides, as they said. So technically all I need to know is that this is x and this is 1.25x, and this is also 1.25x. Okay? If the perimeter of the isosceles triangle is 56, so it's 1.25 plus 1.25 plus 1, which is 2.5 and 3.5. 3.5x is equal to 56. So now let's look for x. So 56 divided by 3.5, we get x is equal to 16. Okay? So find the original base length. So since we denoted x as our original base length, so the answer is just 16. So the answer for number 11 is just 16. Basically just that simple. So this would be our answer. Okay? Next question. Number 12. Given measure A is equal to, okay, so I'll write this down if you can't see it. A is equal to n squared minus 2n minus 4 degrees, and B is equal to 5, B is equal to 5 minus 10n degrees. If A and B are vertical angles, so there had to be equal measure, find the all possible values of n. So they say n squared minus 2n minus 4 is equal to 5 minus 10n. So you get them all to one side, so it's n squared minus negative 10, which is plus 8n. And then 5, negative 4 minus 5 is negative 9, right? It's equal to 0. Because A has to be equal to B. So you kind of just rewrite it to one equation. I'm just skipping that step where we write out the A is equal to B and substituting these sides in. It's just faster. So distributing this out, this gets n plus 9 and n minus 1, right? Because that's n squared, negative n plus 9 plus 8n, and then negative 9. So that works out. So n is equal to 1, and n is equal to negative 9. So which one does not? So we had to check if they both work. So we plug in 1 into this equation, that gets negative 1, negative 5, which doesn't work because you can't have a negative angle. Now you put negative 9 in here, that gets 81 plus 18 minus 4. That's obviously going to be positive. And you put negative 9 in B, that's 95. So this is obviously positive. So negative 9 works. So our answer is just negative 9. Okay. For number 12, don't forget to always check your answers to make sure they're correct. Because when they usually say all possible, what they're trying to say is that there might be some answers that are not possible. So you have to look for all those. Number 13. An equilateral triangle has side lengths x plus y, x, 4x minus 12, and 3x minus 2x. So since it's equilateral, that means two of the side lengths have to be same. So x plus y is equal to 4x minus y. So minus the x from both sides, so you get 3x is equal to, add y to both sides, so you have this. Now if you do the first measure, x plus y is equal to 3x minus, 3y minus 2x, you get 3x is equal to 2y, so which is the same thing. And if you do the second one, which is 4x minus y, and the third one, which is 3x minus 2x, 3y minus 2x, you get 6x is equal to 4y, which simplifies down to 3x is equal to 2y. So technically, this is the same thing for all three of those combinations. So if x and y are positive integers, find the smallest possible value of the triangle. Since they have to be positive integers, if you kind of just look at it, they're both prime. So you just multiply, x has to be 2 and y has to be 3. Because that's the smallest possible they could be for them to be integers. Now find the smallest possible side of a triangle. Since it's an equilateral triangle, they're both the same. They're all the same length. And then one of them is just x plus y. So you technically just have to add these two. So 3 plus 2 is 5. So your answer is just 5 for 13. Basically just that simple. Number 14. The side of a square is one more than the width. Okay, so we have a square. We'll call this side length x, right? And it's one more than the width and 3 less than the length of a rectangle. Okay, so we have a rectangle now. And they said that the side length of a square is one more than the width and of the rectangle, right? So the width, we have width right here, so if it's x minus 1, right? This is one more than it. Now, and 3 less than the length. So it's 3 less, so it's x plus 3, right? So this is our rectangle, And if the area of the rectangle if the rectangle's area is 217 square units greater than the area of the square, what is the square's perimeter? The area of a rectangle minus the area of the square is 2017. So x plus 3 times x minus 1 is just x squared, plus 2x minus 3. And then you have to minus x squared because of that square area, which is equal to 2017. Now you subtract those together, all you have left is 2x. Add 3 to both sides, so that's 220. Okay, so x is equal to 10, 10, right? So if we use your calculator, plus 3 divided by 2. Yes, 10, 10 is our x. So what's the square's perimeter? The square's perimeter is just 10, 10 times 4 because all 4 lengths is the same. So the perimeter is 4040. Okay, so 4040. Basically just that simple. Okay, question 15. 4 coplanar lines intersect at P distinct points. Determine the sum of all values of P. Okay, so let's find the largest possible way that we could have all the lines, right? So we have 4 lines. Let's have a line here, and then like a line here, right? And then we can have actually, show this a little bigger. So have a line here, and then have like a line here, right? So that's all possible. So I chose a line like this because the only possible way is for them to get an intersection is they intersect. I'm choosing 90 degrees because that's the usual way. So then it looks really uniform. And then we have something like this, right? So I have to go through both of those lines. So then that's the maximum possible amount. So you have now 1, 2, 3. Now I want them. Now we have 3 lines, and I want the 4th line to go through all 3 of these lines. So it does something like this, right? So if you kind of extend this line out, we have this point here, this point here. So 1, 2, 3, 4, 5, and 6. So we have 6 possible points. So for 4 lines, the maximum amount is 6. So if you kind of think about it, if all 4 lines are parallel, then we have 0. So we have 0 to 6. Now we just need to make sure all the numbers between work. So can we have 1? Well, yes, we could just have this. Sorry. Right? So you just have that 1 intersection. So so we could have a 1. Can we have a 2? Well, if we kind of do this, that's 2, but if we make another one, that's 3, so that doesn't work. Now, if we make it kind of diagonal, it also kind of doesn't work. And we can't make this the exact same line, because then there's like infinite points that are working, so that doesn't work. You can't have like overlapping lines. So in any way, you kind of just can't make it work. So we have something like this, have something like this, and you have a 3rd line right here, right? And then if we want to make a 4th line, we have to go through another lease line. So if we go through a line here, it has to go through this line. So no matter what, you cannot have 2 intersections. Now can with 3 intersection? Well, yes, it's just this simple. That's 4 lines, 3 intersections. Now can we have 4 intersections, right? Well, can you make a square? Well, yeah, so 1, 2, 3, 4. So that's 4 lines, and then there's 4 intersections. Can we make 5 intersections? Well, basically, it's just the same idea right here. So that's 3, right? But instead of going through all 3 lines, we could just go through 2. So one of the lines is parallel to the other. That's 1, 2, 3, 4, 5. So all the numbers from 0 to 6, only 1 does not work, right? So we cannot use 1. So, but all the other numbers work. So we have a 0, 1. A 1 doesn't work, so we have 2, plus 3, plus 4, plus 5, plus 6. So that's 5, that's 9, that's 14, that's 20. So your answer for number 15 is just 20. Okay. Sorry. Number 16. If order is unimportant and repetition of measures are allowed, in how many ways can one or more angles from the set 15, 30, 45, 60, 75, 90 can be used to form a right triangle? Okay, so the first thing you have to do is that you have to look at the set. So what I kind of noticed that each one is separated by 15. Because 15 plus 15 is 30, then to 45, then to 60, then to 75, then to 90, right? So I know that 90 is just added by 15 6 times, right? So you have 1, 2, 3, 4, 5, 6. So that's 30, that's 45, that's that's 30, that's 45, that's 60, that's 75, and that's 90. So that's 90 degrees in total, and that's a right triangle. So in how many ways can one or more angles from the set? So since repetitions are allowed and order is not important, so you can't have like 30, 60, and 60, 30 because they're the same thing. So since we only have 6 possible 15s, right, and that's the smallest number in the set, then technically the only ways you could have it is that there's either one angle, 2 angles, 3 angles, 4 angles, 5 or 6 angles, right? So you only have this because you only could go up to 6 and the lowest amount is 1 because it says 1 or more. So one angle is self-explanatory. We kind of just draw a box to find out how many we have. 3 angles, 4 angles, 5 angles, and 6 angles. So how many can we have one angle? Well, we can only have one. We can only have 90 degrees, right? Which is possible because we have a 90 in here. Now with 2 angles, we can have 15, 75. So, or you can have 30, 60. Or you can have 45, 45. So that's 3 possible angles. You can't say 75, 15 because that's basically repetition because order is not important. So this is 3. Right? Now, sorry about that. Let me erase that part. 3. Now we have 3 angles. So you kind of think about it. What the reason I wrote these here is that let's say we have 15 for each of them, right? Now we have 3 left over. How many ways can we add those 3 into these 3 numbers? I can add 1 3 here, 1 here, and 1 here, or I can have 1 here, 2 here, and 0. Or like basically I have 2 here, 1 here, and 0. That's basically all the same thing. So these are the only possible like combinations. Or if like I could add a 3 here and 0 here, right? So there's 1, 2, 3. So there's 3 possible combinations. Because like if you look at it, we can have 2, 1, 0, 1, 1, 0, or we have 3, 0, 0. Oh, sorry about that. Let's kind of write it in an order that just makes sense. So you have 1 here, that's 1, 1. You have 2 here, then you have 1 here, then 0. If you have 3 here, that means there's none here, right? So you keep adding 1, so you have to take 1 away from these sides. So you only have 3 possible. And if you have 3, 1 here, that's like 30, 30, 30, right? So that's if you had 2, 1, 0, that would be 45, 30, and 15. And you have 3 here, that's gonna be 60, 15, and 15, right? So you have these angles. So you have 3 here. Now 4. Now you have 15, 15, 15, 15. So you have only have 2 left over. So you either have 2 in one of them or you have 1 split out, right? It doesn't matter which way which one you add to those 15s to. So these are the only combinations. There's 2 here. So how many ways can you make 5? Well, it's just 15, 15, 15, 15, right? So technically, we only have 1 15 left over. And you have to add it to one of them, right? So it doesn't matter which one you add. It's going to be the same thing, so it's just going to be 1. Now, if you have 6, you only have 1 way to make 6. It's just all 6 15s, so that's 1. So how many ways do we have in total? We have 1 plus 3 plus 3 plus 2 plus 1 plus 1. So that's 2, 4, and that's 5, that's 8, and that's 11. So the answer for number 16 is just 11. Okay. Number 17. A straight angle is divided into 3 angles in increasing ratio of 2, 3, and k. If the difference of the measure of the largest and smallest of the resulting angles is 90 degrees, find k. Okay. So we have to find out the amount that is scaling by. The scaling is technically just gonna be the 180, right? Because of all 3. So that's 2 plus 3 plus k. That's going to be the scale, right? Because if k is equal to 4, that's like 5 and that's 9. So that's 9. The 180 divided by 9 is 20. So you scale each one by 20. So you have 2, 3, and 4, right? You make this scale by 20. That's 40. That's 60. And that's 80. So that's 120, 180, right? So that scales up. So this is our scale. Now we have to multiply this by the largest number, which is k, and multiply this by the smallest, which is 2. And then when you subtract them, you get a angle of 90. So technically all you have to do is just k minus 2. Which is just k times this number, which is scaled, and then 2 times this number scaled, and then you have to subtract those two, right? And that's equal to 90. So we divide 90 from both sides, so the 180 turns to 2, and this turns into 1. Distribute the 2 to this k, so that's 2k. 2 times the negative 2, that's negative 4. Now make this go to the other side. Since this is divided by, you just multiply from this to both sides. So this is 5 plus k. So multiply 5 plus k from both sides, and you get 5 plus k. That's 1 is just going to be the same thing. So minus the k from both sides, so k minus a negative 4 from both sides, that makes 9. So k is equal to 9. As simple as that. That's basically how it is. Okay. Number 18. Below is a rectangle with area 150. Okay, let's kind of draw this out. We have somewhere here. Oops, sorry. We have somewhere here, here, then back down here. Okay. And we have a length here, we have a length here, and we have another length right here. Okay. So below is an angle. If A is the midpoint of R and T, so this is the midpoint. So this side length is the same as this side length. And O and P trisects RE. So this length is equal to this length is equal to this length. I'm using different variables so you know that they're different scaling. So find the area of CAP. CAP is this area, so the triangle. So technically all we have to do is that we need to find this area, and this area in relation to the entire thing. So you kind of think about it, if the entire area is 1, right? Then this side length is 1/2 of the side of the height or width, and then 1/2 of the width, and this 1/3, 1/3, 1/3, right? So this area, which is a triangle, is just 1/2 of the height times 2/3, because it's 2 y's, 2/3 of the length, and then multiplied by 1/2, because that's the area of a triangle. So that's gonna be 1/2 times 2/3 times 1/2. So that's gonna be 1/3, 1/6. So this entire thing is 1/6 of the entire thing. Now this is 1/2, and this is 1 of 1. So 1/2 times 1, which is 1/2. And then since it's triangle, you have to multiply the other half. So this is 1/4. Okay. So this is 1/3, and this is 1, the entire thing. So 1/3 times 1 times 1/2 is 1/6. Okay. Now, if we have this entire thing, we just have 1 divided by 6 plus 1 divided by 6 plus 1 divided by 4. So that all these areas added together is equal to 7/12. So in the middle, it has to be 5/12. So since the entire thing is gonna be 150, and the triangle is 5/12 of that area, it's just multiplied by 5 divided by 12. And you get an answer of 62.5 as your area. Basically that simple. Number 19. Each angle of a triangle has a prime degree measure. What is the measure of the largest angle possible? Okay, first you gotta think about the primes. So if you have two primes, right, as the small side length, since a prime is usually an odd number, an odd plus an odd is even. So the last angle, since you have 3 angles, right, this is a triangle, then the last angle has to be even, because odd plus odd equals even, and a triangle measure is 180. So 180, which is even, minus an even, is basically just even. So you can't have that. So one of the angles have to be 2 because that's an even prime. So even prime plus an odd prime is an odd prime. And at 180 minus an odd prime is going to be odd. So 2. And now we can just list a bunch of odd primes. So we say 3, 5, 7, 11, 13, 17, right? So I'm starting for the smallest value. So then the largest possible angle is going to be like if we check those as a prime, then it's going to be the largest possible prime. So 2 plus 3 is 5. So this is 175. Does this work? Well, 175 is divisible by 5, so that doesn't work. 2 plus 7 is 7. So 180 minus 7 is 173. Is 173 prime? 173 is prime. So this is our largest angle. Basically just that simple. 173. Okay. Now let's go to number 20. So number 1973, you didn't catch me on that. Okay, so 5 rods with measure 4, 4, 5, 5, and 6 are placed in a box. If 3 of the rods are drawn randomly from the box, what's the probability that a triangle formed from the selected rods is scalene? So a scalene means 3 different sides, and we have only 4, 5, and 6, so we have to get one of each. So we have double 4s, double 5s, and double 6. So we have a 4, 4, 5, 5, and 6. And we have to grab 3 of them, and it has to be scalene. So technically, the probability to get a 4 first is 2 out of 5, and then we need to get a 5, which is just 2 out of 4 because you already took one out from the beginning. And then since you already took another one, that's 3, and you have to get a 6, so that's 1/3. Right? So it doesn't matter which way you're going to do it. It's going to be 4. You could take a 4, 5, 6, 4, 6, 5, a 5, 4, 6, a 5, 6, 4, a 6, 4, 5, or a 6, 5, 4. So there's 6 possible ways, right? So you have 6 times 6, basically. And this is your answer. So how do I know that it's going to be these numbers? Like, doesn't it change because you use 4 first, then 5, and then 6? Well, not really. If you kind of think about it, you're just going to be shifting out the numerators and the denominators. Denominators are going to stay the same because it's going to be out of 5, and then out of 4, and then out of 3. Because you're taking 1 from each of them. But then it doesn't matter. So if you choose like the 6th first, it's just 1. And then you choose the 4, and then you choose the 5. It's just 1, 2, 2. It's always going to be a 1 and a 2 and a 2. So you just have to multiply that by 6 because that's the 6 possible ways you could do it. So 2 and 2 here cancel out with this 4. This 6 cancel out with this 3. It leaves the 2 on the top. So we have 2 over 5 as your answer. So number 20 is just 2 over 5. Basically just that simple. Well, that basically covers everything for the CCML Geometry Contest 1 2017, 2018 Division A. Thanks for watching, and I'll see you at the next math record.